So again, area equals pi r squared. We have 3 circles. Your job is to find the area of the 3 circles. So if I have a radius of 4 centimeters here, I know that my area is going to equal pi times 4 squared. What'd you get for an area? Julian, what'd you get for an area for the 4 centimeter? Yeah. 16 times pi is 50 point what? 24. Yep, you're going to have a little bit different answers depending if you use the symbol pi or 3.14. So if you're close to this. And you need to make sure that when we're doing this, these are units squared. So here, because we're measuring centimeters, this is centimeters squared. Over here, this one would be area equals pi times 5 squared. And I get an area of 78.5. Sure. Okay, squared. And make sure you have centimeters squared as your unit on the end of that. The last circle, the biggest one, is area is going to equal pi times 6 squared. So it's basically pi times 36.
I got 100.5.
What?
No. It's 113. Okay. Centimeters squared. Okay. So that was step 1. Basically, all we had to do was follow the formula for an area of a circle, plug in our radius. Another way that you might see this is area equals, and you want to probably write this one down, is pi times diameter divided by 2, then squared. Because we know that the radius is half of the diameter. So but if you're given diameter, this is the formula that you would basically use. You take the diameter, divide it by 2, and then square that answer. It's the same as having r squared. This is a lot harder of a question here. If I was to use my answers in area as well as radius, okay, my information in radius, can I make a statement about how the area changes when the radius changes? What would be a statement I can make based on our findings?
Oh, you can say that they change.
As the radius increases,
Yeah.
the area increases. Okay, that would be one statement I can make. Can we get even more specific?
Say that
As the radius increases by 1, the area increases
By like 30.
26 to 30 range.
Okay, so it's kind of like a range according to our answers, right? Increases by more than just a little. If this is 4 centimeters, what's the diameter of this object? What? 8 centimeters, okay. And what would be the diameter of this object? 10 centimeters.
Well.
And what would be the diameter of that one? 12 centimeters. Okay, well, the diameter definitely is increasing by 2. The radius increases by 1. Diameter increases by 2 from each circle. Yeah. What about like this area thing? This is a linear relationship. You just can't, it's hard to see. And the reason why you can't see it is because of r squared. We're not used to looking at numbers being squared. We're used to looking at numbers getting twice as big, 3 times as big, 4 times as big. We can see those patterns. This pattern is a lot harder to see. So if the diameter is 8 on this one, right? What's the circumference of this circle?
Oh, if I did that instead of that.
Yeah, diameter times pi. What is it?
12.72.
Wait, no. 8 times pi.
25.
Yeah, go. 25.
25.12.
Okay. So it's 25.12. If I was to take 50.24 and add 25.12, am I going to get pretty close to that? Yeah. I'm going to be at 76 something. It's going to be pretty close. So what's 10 times pi? If the diameter of this, 10 times pi is 31.4. I just know it, right? Because it's by 10. So this circumference is 31.4. 31.4 plus 78. Does that give me close to...
Because
It gets pretty close, doesn't it?
it gets pretty close, yeah.
But it's not exact, is it? So it's almost like the increase, in size in area is the area plus the circumference. Almost.
To add like the point two, it's not only the first one.
Yeah.
So
They're kind of all just a little tiny bit off, but not quite. That's just something to think about. But it has to do with the square. That's why it's hard to find exactly what that pattern is. Any further questions about area and how to use pi and r squared in finding the area of a circle? That's what we're doing today. We're identifying an increase in area when a circle increases in radius and diameter. So basically what we did is a good warm-up for the rest of today.